Yesterday we had a whole... Why, hello. Alright, so yesterday we had a whole bunch of folks that were testing, other things were going on, so I just want to do a quick recap of where we were. I think in the unit guide, the page before the one I'm on, there should be some space there. I want to make sure that you get this copied down somewhere. So yesterday we started looking at what happens when it's not just one function. What if we've got two different functions and we're looking at the area bounded between these two functions? This was like the big idea yesterday. So if I said, find the area bounded by, and make sure you get this copied down. If I want the area bounded by these two functions, just bounded by these two functions, I want to get some hands on this. What would you do? Where would you start? Area bounded by these two functions. Jose's got some ideas. Delia's got some ideas. Jackie's got some ideas. Delia, where would you start?
Would you look at the intersection?
I would want you to look at the intersection points. Why are you going to look at the intersection points?
Because you're looking at, you have two different functions, so you have to look at both.
Okay. Right, I'm looking at the area bounded by these two functions over here, so you're going to find the intersection points. Now, if it's calculator active, finding intersection points not too bad. We get this under control. Okay. If it's calculator inactive, you're going to have to do a little bit more algebra work to get there. You're going to do the work, but you're going to be okay. So let's say you've got the intersection points now. It's A and B. Delia is frozen. What do? Your goal is to find the area bounded by these two functions. What do you do next? Only Jackie? How would you find the area? What are you looking for, Benta? What would you do?
I would make
An integral? Yes, you'd find an integral. Keep it going. Don't shake his hand yet. He hasn't done much. Okay, so you're going to do an integral. Tell me more.
And then you have to take the graph from the top.
Yep.
And then subtract the one minus the one on the bottom.
Okay, the function that's on top minus the one on the bottom. Why? Not Beto. Why? Why top minus bottom? What are we looking at here when we think about top minus bottom? This is a really big idea, and I'm worried that nobody's with me on this conversation. Why top minus bottom? One more time? What we're looking at is I like to call it those representative slices, or we think about it as the rectangles. It's what Riemann tells us to do, right? With each rectangle, now this rectangle, what's the top and what's the bottom? F of x is the top function. The bottom function is g of x. So the length of this rectangular slice right here is f of x minus g of x. What's the area for the rectangle? We know the height. How wide? Well, it's not just where does it start and where does it end. That's what the dx represents, or that delta x. So you're integrating f of x minus g of x. You're integrating with respect to x because what this is telling you here is the area for the rectangle. Now, I know we're still relatively babes in the woods here, so that's f of x minus g of x. The issue, though, is, are all the rectangles going to be f of x minus g of x? What if I draw a rectangle here? What if I draw a rectangle here? Are they all having a height of f of x minus g of x? Every single one of them? So what that means is I can get away with doing one integral from my starting point to the ending point, and all those rectangular slices have this form, f of x minus g of x, integrate with respect to x. Big idea, are we okay with that? Peter, are you okay with that? So what if I asked for the part that is bounded in the first quadrant by these two? Have a conversation with the folks around you. How does that change things? Don't talk to me, talk to your neighbors. How do things change the area in the first quadrant?
They're going to be from 0 to wherever b is, right? From 0 to, well, it's not going to be 0 from b, it's going to be wherever b is, like the x value of b.
First quadrant only.
That's what I was saying.
All right, let's get some hands on this. What's different? I don't want... Okay. I'm not interested in your final answer.
Oh.
What are some things that are different? Jackie, something that's different.
You're gonna focus on smaller amount of area.
You want a smaller amount of area. So what do we get rid of now?
The second, third, and fourth quadrant.
Okay, so second quadrant, gone. Third quadrant, gone. Fourth quadrant, gone. You've just changed your shape. So that's changed. You're frozen.
Oh.
What has to change now? Yeah, Jose.
The A has to be 0.
Your A has to be 0. Like the A, the intersection point. You're not interested anymore because?
Because you're looking for the first quadrant.
You're only interested in the first quadrant. Everybody okay with that?
Yeah.
Okay. So when you do your integral, where do we start? 0. Where do we end?
B.
B. Everybody agrees?
Yes.
Okay. What are we integrating? Look at the slices again. Have those changed at all?
No.
Think about your slices. How long is this slice right here?
It's gonna be g of x. I mean f of x minus g of x.
F of x minus g of x? I disagree.
Isn't it?
Top minus bottom. Which one's on top? Which one's on bottom? F of x is on top, I agree. Which one's on the bottom?
X.
X?
No. 0. Y equals 0.
Y equals 0. The x-axis is what's on the bottom now. So what happens for this slice right here, the height is just f of x, or f of x minus 0. So you're going to integrate f of x from 0 to b. Roberto seems comfortable with that. Jose doesn't seem comfortable with that. Beto doesn't like that. Jackie's got some concerns. Is the integral from 0 to b of f of x going to give us that area?
No.
Roberto, I haven't heard from you about what. Why not?
Because we need to find the intersection.
What intersection point?
B.
B? Don't we already know it?
No.
No. No. A would just do it because that's bound.
We're starting at 0. We are going to end at B. There is a problem, and I haven't heard this from anybody yet. What's the problem? Think about your slices. It's about the slices. Jackie, what's
It's
the
gonna
issue?
be too much. It's gonna be an overestimate.
Right, if you go all the way from 0 to B, think about your slices.
You have a triangle.
Are they all starting on the x-axis and ending on the curve?
No.
No. Where does that stop being the case? At this point over here. This point over here now becomes important to us. So maybe you want to call this C, right? The root. I know, like, we don't actually have a graph, or we don't have, like, anything to put on the calculator. But is everybody okay? Like, this root's really important to us now.
So you add another integer.
But you've got to first fix this one. You're going to integrate from 0 to C to get this area. And how about the last part?
From C to B.
From C to B, we're going to do an integral.
F of x minus g of x.
And think about that slice again. Now we're doing f of x minus g of x dx. You have to pay attention to the region. Once you know the region, you want to think about those slices. Okay, you guys are in a pretty good place. What I want to do is have you show me what you can do. So with your calculator, this is 100% calculator active. No one's going to get help from anybody else. You've got 4 minutes to do this introductory problem on page 9. I want to be a proud papa with this one. My advice with all of these problems is take the time to sketch the region. Understand the region, and then your calculator is going to do all the heavy lifting for you. And then we'll go from there. Pedro? I don't know why you're a professor, but you're a professor now. Kayla. Jackie. Carlos. Jose. Leo. Jose Perez. Ashley. There's my Ashley. Ashley. Juan. There you go. Juan. Kevin. Delia. I know I totally distracted your focus by giving you the test, but I'm going to move you in a little bit. You've got 3 minutes left on this problem.
I felt good on having multiple choice and I literally got multiple choice. But my first ones I felt good and only got
I know you're going to feel a lot better had you taken that on the Friday before the break.
but I
It would have been much better.
I don't know how to do this. Tackle this and what is the
Sir?
other page? What is the other page? Because I know it's element, natural law, well, and then X minus 3, but what's the other one?
oh my god.
See what I'm saying?
So would it
Make sure you understand the region. Part of the challenge is going to be making sure you know what you're looking at.
it would look like this?
If you've got a good graph, life gets that much better.
Ooh, I want that.
Is that what it is?
Are you guys done already? Wow. Haven't even done much.
So basically the question's gonna be element and then you plug in y equals negative 1, so you're gonna have a straight line.
The area that you're looking for, is everybody okay that it's going to be this one over here?
Yeah. I know I didn't call that until like.
That's the area that you want. Well, how are we going to get that area? I mean, we can do an integral. Where do we start integrating? Where do we end? Jose, where do we start? From 3. Why 3? Are you talking about the vertical asymptote?
Yeah, vertical.
Okay, we're not going to start at 3. Starting at 3 is going to get you nowhere. Name, where do we start?
The intersection between y equals -1 and the...
You want to start at this intersection point of y equals -1 and y equals natural log of x minus 3. And that doesn't happen at x equals 3. What is the intersection point? What'd you get, Delia?
3.367,
3.367.
and then the y value.
And then you've got a y value. Now, do I need this 3.367?
You can just put. or
Right,
you
do I need this in calculations?
can- No.
Yes.
You can store it. You can
That's why, because we need it, I want you to store it. And this is where I want to make sure that we've all got the skills. Okay, so Beto is still graphing. Okay, we're going to integrate from this 3.367 to where? You're going to stop integrating here when you get to the edge, which is 8. What are you integrating? This is when you come back to your rectangles. How tall is that rectangle going to be? top minus bottom. So the height is the natural log of x minus 3. That's the top function. What's the bottom function? You want to know the length of that rectangle, so it's natural log of x minus 3 minus -1, top minus bottom. So we've got the natural log of x minus 3 minus a minus 1 is the same as plus 1. And you're going to integrate that with respect to x, and Beto is doing his best to catch up with me here. Okay? In terms of points, if you have the integrand correct, you got 1 point, natural log of x minus 3 minus -1, or natural log of x minus 3 plus 1. If you've got your limits of integration correct, the 3.367 and the 8, that's your second point. And then you're just going to type all this in on the other screen, so you go over, and menu, calculus, numerical integral. Beto, did you store the 3.367? What did you call it?
Okay.
Okay, so just make sure you write on your paper k is 3.367. Especially if you're going to say like k to 8. And this is f1 of x plus 1, or minus -1, same thing. Integrate with respect to x, and we get 8.415. How many of you guys honestly hit 8.415? Okay, we're moving in a good direction. So 1 point for the integrand, 1 point for the limits of integration, 1 point for the numerical answer, grand total of 3 points. What I want to do is I want to give you guys the next 12 minutes to work on some sample AP multiple choice questions. I want to move you around. Where are the superhero cards? So you can work. You cannot work with one of your current peeps. You need to move. 1, 2, 3, 4. 4. You can work with anybody in the room that you want to, but it cannot be a matching superhero. You guys can thank me for that later. All right, find a new partner, please. For the folks watching the video at home, we're going to work on the multiple choice questions on pages 10 and 11 for the next 12 minutes. There's not going to be much happening up here, so you might just want to fast forward the video 12 minutes to where we're going to pick up. All right, with your new partner, stay with me. You've got 6 multiple choice questions. These are all released AP exam questions. Some of them are calculator active, some of them are calculator inactive. Make sure you're paying attention to the instructions. You should be able to get through at least the first 4 in the next 12 minutes, but don't let 4 be your goal, let 6 be the goal, but realize that 4 is probably the right goal. So thanks for all the support.
Mr. D, isn't we doing
These are about the same thing.
the problem? We're doing the next page. Oh,
Pages 10 and 11.
never mind.
The 6 multiple choice questions. Don't worry, Delia Benitez. No one knows. It's just between me and you and the folks in the room. It's not like this is going to be on the internet. Years later, kids are going to say, why does Delia Benitez not know where she's supposed to be doing?
Equal to y and over the y. Yeah, myself to find c.
Nice. Nick, I need all the superhero cards back.
What superhero is that one?
Which one did you have?
The Hawk one.
The Hawk, that's Hawkman, or Hawk.
Yeah, I got that.
Technically, she's called Hawk Girl, but that's a problem.
Graph, because of the and then it says
Three,
Sunday with the
need
y
one more
axis.
superhero card.
instead of the x-axis, so you find the intersection. Right there,
We don't integrate to the thing here.
and now you're only gonna look at this triangle. That's all you're looking at.
Don't about the grass and why you, so this area right here.
Then you look at zero triangle.
Is this what you store at 0.73?
There you go, big that area right there.
39.
It's this
So
area.
that's not what you're looking at.
Oh, I thought you said about this one.
That area right there. Yeah, that area right there. No, this one's bounded by the x-axis. You look at this one. You have it now, bro? It's bounded by this graph. I don't know how to draw triangles.
Oh, okay.
Save yourself the trouble.
I said I kind of get
Anyway,
Here.
We found the intersection though.
Oh.
For this point,
Yeah.
it said
Because we're doing-
0.7. This one over here, is it accurate or it's not?
So the line y equals x passes through the origin, so that is the point 0, 0.
So that's
Mine
our
was points.
Yeah. So you're going to integrate from 0 to 0.739, and most students will figure out the limits of integration first. Now you got to tell me about the integrand. What are you integrating? Disagree. If you look at the region you're trying to find the area of, the region that you're in, right, your region looks something like this, and you want that. So we know that you're starting at 0. You found the intersection point to be 0.739, so you know that.
Yeah.
But how do you find the area? This is where you want to draw those slices. How tall, like how long is each rectangle? You're starting on the graph, or your top function is cosine of x. Your bottom function is x. How long is that slice? It's going to be top minus bottom. So it's cosine of x minus x dx. Because we're constantly looking at how long is the slice. If it was cosine of x, that would be if you went all the way down to the x-axis. And that's not what we're trying to do. Okay, what did you guys get for number 1? C. Okay, keep going. Second one is calculator inactive. Okay? I know, yes, for those of you that need translation support, it says no calculator, so no calculator. Yes. Right, so the difference is on the calculator active question, you get here, you get your setup, you're like, oh, let me go to calculator. On the calculator inactive question, you have to say, oh, now I need to find the antiderivative. Then I need to evaluate, then I need to.
It's like mini SAT.
These are seven questions. You have to grab it by hand, section points by hand. You have the skills.
You put it 3 times and then you think not even that.
Because, so, my plan is, if I don't go to Xavier, and I don't go to PB, I'm going to school in Houston.
Which is why, Abraham, you're not interested in this that's over here, because this is bounded by the y-axis. Cosine of x, y equals x to y. This wedge and Delia. Hold on a second. Nobody needs that in their life. Okay. Keep working.
Okay, so x squared is like multiplied
Yeah.
and then this is y equals x squared.
Yeah.
So how do you know what you should look at if it goes from 0 to 2?
Well,
I just cried.
so here's y equals x squared. Here's y equals negative x from x equals 0.
When I got in, I was like, I was really gonna.
What region is bounded by all four?
You know how we do that? Are you going?
Not over here, because that's outside of the bounds.
And
Like
then
for you to pay,
what's
you got your financial.
maybe
That's the key thing.
$57,000.
Because it has to be bounded, it has to be trapped by x squared, negative x equals 0, x equals 2.
My number one is 32. My number two is 32. And 66.
Because you're like jumping into part of the issues you don't have. X squared
Because it Texas State was my first acceptance.
I mean,
It was a
sketch.
quick acceptance.
So part of the issue, Jose, and for some other folks, is if you don't know what the graph looks like, okay, can I take your graph? When you're going like all the Here's y equals x squared, here's the line y equals negative x. You're integrating from 0 to 2, okay? So this beautifully, I mean, I think we were going to go into a different shading technique. This is the region that you want to find the area. Don't just start integrating.
He didn't even let me slide
So
over.
this is the region. So where do you start and where do you end?
To sleeping class. You got some good grades.
I'm good with
Last semester.
No, I didn't get, I don't have the money.
Okay, and that intersection point, they both pass through the origin, so you're integrating.
where did you put the
Now, what are you doing? I never done it. You got that. That's why I wanted to draw those little rectangular slices.
No. He
If
didn't do
you
anything.
draw
He
little
just
slices,
said,
it's
scratch
paid
for
by.
money.
Guys, you remember.
At school, I'm homeless.
How long is it?
X squared was
Because I always have these stuff. My mom doesn't buy them. My uncle doesn't buy them. They exploit me. I'm the favorite. I'm the favorite
Now
niece.
you got the graph.
One of them, he doesn't have
And do we determine the slice, the length
And
of
then
the
like
slice the
my
same
dad's
way?
side, I see them, and my aunt will give me whatever.
X squared is on top, y equals negative x is always on the bottom. That's the thing.
You're doing 1 and 2?
So you're going to do interval 3, 2,
Like he works, but we really he doesn't do shit.
You get a...
He took me to the that was even shit. You drove to, I was not together. I was like, my mom would get in the car and leave me away. But I was like, I don't want to drive. My mom was lonely. Teacher don't get paid shit. My mom ain't working. I don't know how she making it less salary. But she did. And now I've been applying for more jobs. Because I had a job, but I had to stop.
So you're doing some right things.
Because you know how we had Harvey, it threw off everything. So it threw off our schedule. And then our schedule started going on for the ice thing.
Are you kidding?
When I got my lesson, when I put my dad first got this thing, girl, he was
Why?
Remember, you were there. Well, you were there, remember? When we used to sit at the night table and
he was
we
kind
were
my mom bought it. I think she bought 2 charms.
I was there before all these things.
Like around holidays, they come and buy 2 charms and give them and the charms like $50. And I was for 2 charms of birthday.
Everyone's trying to go.
And she bought this thing. No, my cousin bought me this thing. And my aunt bought me this thing. And I need to go take it again because I got an appointment and I forgot it. At least it didn't run 30. It's just dark now.
Oh, maybe.
Cause you know.
Thank you.
Oh yeah. She's like, I don't want to do it.
He's like, no.
Is the second one?
Yes, keep going.
Three is D.
I would take the natural log of both sides, that would work.
I know. You just look at the graph.
Nice, good, keep going.
Because they said they were easy, they were like, I don't get it.
So do you just plug these in?
Alrighty, friends, I need to stop all the fun. No, you don't quit. Of course you don't quit. You're a DeRozier. Okay, or close. Alright. We get 16 minutes left. I want to tell you what the answers are. I think I checked in. Everybody had C for number 1.
Yeah.
Number 1's easy because you get the calculator. But you've got to be able to do this without the calculator, and this is where we're going for the rest of the time. Number 2 is D. Number 3 is D. Okay? If you're getting these right, you are in a good place. Number 4, I don't think many people made it here yet. Number 4 is D. Number 5 is going to be C. And number 6 is going to be B. Okay, so this is just extra study material as you're getting ready for the quiz on Monday. I'd look here. Yes, dear.
Are most of the questions that we're going to do going to be calculator or no calculator?
Great question. Both.
But more of...
None your business. Okay. All right, more of none yet. All right, I want you guys to go back to page 9. And so here's where we are. You all are in a very good place. I think we're making some good progress, especially when it comes to the calculator. Life is good. Up until about 2 years ago, what we've done so far is all that we would do. And I'd say, okay, check area, and we move on to the next topic. And that sets students up to be successful about 90% of the time. I want to go after the last 10% right now. I'm not going to break anybody in the process. That's not my goal. But if you're doing well so far, you're ready for 90% of the area questions, but we're going to go for that last 10%. All right, so I want to look at this problem one more time. Make sure you're on page 9. Calculator inactive. Your world is about to get rocked. But I wanted to build up your confidence first before I dash it against the rocks. Okay? So let region R be defined as the section of the xy plane which is bounded by the curve f of x equals the natural log of x minus 3, the line y equals -1, and the line x equals 8. You might say, Coach, didn't we just do this problem? Yes, but with a calculator. We need to do this without the calculator. So where do we start? We have f of x. Ashley needs to put the calculator away. We have f of x equals the natural log of x minus 3. We have y equals -1. And we have x equals 8. We have no graph. You have no integral yet. Get me the graph. Anybody know what the graph of natural log of x minus 3 looks like? Anybody know what the graph of natural log of x looks like? You guys draw that in the air for me? What does that look like? Natural log of x. If you're not sure, look around the room. Look at what the smart kids are doing. Okay. Name got bigger. He's like, look here! Okay. Y equals the natural log of x looks like that. It's got a vertical asymptote over here at x equals 0. That's the graph of natural log of x. But Jesus, what about graph of natural log of x minus 3? How's that different? Jesus, how's that different? Shifted to the right 3 spaces. So now I've got a vertical asymptote over here at x equals 3. and my graph increases. There we go. Natural log of x minus 3. Okay. Y equals -1. Do we know what that looks like? What is that? Straight line. It's a horizontal line. X equals 8. Vertical line. Okay. The region that you're looking for is that guy here. I would hope that for the most part, we're okay so far. Now what? How are we going to find the area?
Rectangle.
Okay, so
Integrate.
Jackie wants to go to the rectangle. That's fine. Go to the rectangle. So we're going to draw the rectangular slice. And you've got to ask yourself the question, how long is the slice? Or how tall is the
It's
slice?
gonna be L of
ln
x minus 3
ln of x minus 3
minus
minus -1. Is everybody okay if I just make that +1?
yes.
Okay, but here's the thing. Before you settle on this, is that the height for all of the slices?
Yes.
All the way from your start, all the way to the end.
Yes.
Every single slice is the same. Good news, you're going to integrate the natural log of x minus 3 plus 1 with respect to x. That's great. Now what? Jackie's frozen for a little while. Jose, what do you got? Sorry, Jose Pete.
Well, we know that the end, like B is 8 because you're in it.
Okay, you know that you're going to end at 8?
Yeah.
Right? And if we're doing like multiple choice, we're going to do process of elimination, you know you're going to end at 8. Where do you start? You start at the intersection point. Now, before it was easy because you had your calculator. You no longer have your calculator. What's the algebra here? I want to get the intersection point.
Equal natural log to -1.
You need to say, where is the natural log of x minus 3 equal to, whoa.
Ooh.
Whoa! Right? It's where does this curve intersect
Where was
that
his
line?
mind?
Where do they intersect? Specifically, you want the x value, which means you need to solve this equation. At this point in the calculus course, solving something like this should be pretty straightforward. How do you feel? How are you going to solve it?
Oh,
Good, how about you?
Exponentiate on both sides because the e and the ln are inverses. Okay, don't leave me yet, Kaylin. X minus 3 equals e to the -1. And then you're going to add 3 to both sides, and x equals 3 plus e to the -1. And everybody's okay. Juan, you need to wake up and take notes. So now here's the thing. What is 3 plus e to the -1? I don't expect any one of you to know what this is as a number. You don't need to know what it is. Do we have our bounds? Yeah. Do we have our function?
Oh, we could leave it like that.
Yes, but now here's the problem.
No calculator.
It's no calculator. So what do you do? What's the next thing?
You do the antiderivative.
You need to find the antiderivative. And so now I need to ask you the question, what's the antiderivative of the natural log of x minus 3? Stop saying 1 over x minus 3.
1 over.
Because I asked for the antiderivative.
Not
And
the
all my
derivative.
1 over x minus 3 people are telling me
The derivative.
the derivative. What's the antiderivative? Maybe you want to check the poster above Kevin's head. What's the integral of natural log?
You don't know?
It's not there. You didn't learn it because to integrate this requires advanced integration techniques.
Some I don't have.
Okay, so this is,
That's unfortunate.
if you're in calculus BC, eventually you're able to do this. Right now, you're stuck.
And then into
Okay, but stay with me, we still get 8 minutes left. Is everybody mostly okay getting to this point?
Yeah.
Ashley, you with me?
Is that final answer?
Getting here, we're okay. But because you don't know how to integrate the natural log, you're stuck. So, what did Riemann tell us to do? What did Riemann tell us to do to find this area? Rectangles, right? And so he said, make a rectangle, make a rectangle, make a rectangle, make a rectangle, and then add them up.
Yeah.
Okay, at no point did he say how you had to make your rectangles. I want to redraw this. If you could redraw the graph.
Are you gonna draw them horizontally?
One more time?
Are you gonna draw them horizontally?
Absolutely.
Oh.
Okay, get the graph recreated.
Calm down.
We're going after that last 5% that I did not teach well or at all in the early days, but now I have higher expectations. Yeah, that's it. Riemann never said that your rectangles had to go up and down. He never said that. Think about it from an area standpoint. Could you find
Yes.
the area of a rectangle that goes that way?
Yeah.
Absolutely. And if you found that area, and then you found the area of all these other rectangles, and you added them up, would that still work?
Yeah.
You're going to get exactly the area that you wanted. Now the difference is that these rectangles are horizontal rectangles.
Wait, Mr.
Yep.
Why again? Why are we not doing them horizontally again?
You mean vertically?
Yeah, sorry.
Because we tried vertically, and then remember we got to something that you didn't know how to integrate? That's why you get stuck. Everybody still with me?
Yeah.
Okay, when it comes to the horizontal rectangles, what I want you to do is turn your head and think of it this way, or maybe you want to think about it this way.
Oh.
It's the exact same thing you were doing, except you're going to go this way.
Just turn the paper around?
Or you could just turn the paper around. Here's what's different. With horizontal rectangles, it's a dy integral. I want to say that again. When you do your slices, you're changing the y values because this is how you're moving. What that means is your limits are going to be in terms of y. Your integrand is going to be in terms of y. Everything is in terms of y. Everything changes now. So, where do you start integrating?
Y
Everything's in terms
Negative
of
1.
y.
Negative 1.
Right? What's your lowest y value?
Negative 1.
Negative 1. So you start at y equals negative 1. And you rectangle, 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 until you get to the highest point, which is like right here. Now here's where you got to be careful. What are the coordinates here?
8, comma...
I agree, 8.
8, comma something.
8 comma something. 8 comma what, Pedro? 8 comma natural log of 5. Pedro, where did natural log of 5 come from? Right, you're just plugging into the curve natural log of x minus 3. So you start down here at y equals negative 1, and you slice, 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 until you get to the highest point, which is natural log of 5.
That's 8, comma natural log of...
8 comma natural log of 5. You take the natural log of 5 because you need the y value. 8 minus 3 is 5. Okay, now, how long is each rectangle? We used to think top minus bottom. But here's where you got to be careful. If you were slicing this way, top minus bottom, we're slicing this way,
Bottom. Minus top.
not bottom and top at all.
Left and right.
Left and right. Which one's first?
Right minus left.
It should be right minus left. In a dy integral, it's right minus left. Stay with me, we're almost there. So what's the function on the right? Which one's on the right? 8 minus, which one's on the left? X equals 8 on the right.
Natural log.
Natural log of x minus 3 is on the left. You've got your limits of integration. you've got your integrand. There is a problem, and I wonder if anybody sees it.
Do we now need to find the
ln
antiderivative?
Pedro, what's the matter?
the second ln is not in terms of y.
The ln is not in terms of y. This is a dy integral. Today is his day. Whatever you had for breakfast, keep doing it and bring some more. Okay? You need this to be in terms of y. There you go. If this is the function y equals the natural log of x minus 3, what you need to do is change it. Change it so that it's the same function, but it's expressed as x equals. How do I get there? I'm going to exponentiate again. So e to the y equals e to the ln of x minus 3. These guys cancel. E to the y equals x minus 3. Add 3 to both sides. E to the y plus 3 is equal to x. It's the same curve, but this was y equals form, this guy's x equals form. Which means that your setup is now 8 minus e to the y plus 3. We've only got a minute left. But look at the calculus now. We got here before, but we got stuck because we didn't know how to integrate. Do we know how to integrate 8? What is that? The integral of 8 is 8y minus the integral of e to the y is e to the y plus the integral of 3 is 3y from -1 to the natural log of 5. You can clean this up a little bit if you want. 8y minus all this is the same as 5y minus e to the y. Stay with me for just a second. And now you're going to plug in. You plug in the top guy. 5 times the natural log of 5 minus e to the natural log of 5 minus plug in the bottom guy. 5 times -1 minus e to the -1. In this particular problem, switching to the horizontal rectangles gets you to a point that you actually can integrate, which was the problem before. Vertical rectangles didn't work. We went to the horizontal. All right, nice job.